right, so we're going to look at how to find domain and range when you have a continuous graph, meaning we don't have just points. In our previous lessons, we found domain and range by, looking at points and then just writing down the numbers. But now we're going to look at domain and range when you don't have just points and we have like shapes or other types of graph. Let's look at the domain first. So domain is on the x-axis, so you're measuring like how wide the graph is, okay? I'm gonna come back to this question. Let me just start with this one. This might be a little bit easier. So we're gonna look at the domain, see what on the left looks like it's starting at -4, and then it's going all the way to the right. So this is the length of the graph. So we're gonna say that in words, the domain is from it's going from -4 to +2, okay? But we don't usually like just write it like that. We use math notations to write it. So there's two ways we write it. You do need to know both the ways. The first way is set notation. So set notation gives you a set of numbers. So obviously I can't write -4, -3, -2, -1 because there's also numbers in between like -3.5 and so many numbers in here, right? So we're just gonna give it, just say that we're gonna, the domain is between -4, and then we use this less than or equal to x less than or equal to 2. Okay, so what this means is my x values are any number that is greater than -4, but less than 2. Okay, so basically that just means it's between -4 and 2. Okay, this is set notation, and we use inequalities to show that it is between these two numbers. Okay, and then for domain, for interval notation, we use parentheses or brackets. So for example, right here, we're going to give the two numbers is between -4 and 2. And then we're going to use a closed bracket, a square bracket, to show that it's included. I'll show you when it's not included or things like that, like open circles and things like that, but we'll do that and then some examples coming up. But the main thing here is to find the domain and be able to express it using inequalities or interval notations, okay? And then now I'm going to come back to this problem right here. So for this problem, you notice that the graphs are actually going off the graph, right? I'm gonna go ahead and put an arrow. Usually there are arrows, but this one doesn't. But it means that it keeps going. It doesn't stop. When it keeps going, that means that it's going on the left side is going to -infinity, and then on the right side is going to +infinity. So basically, the domain is the all real numbers. It's going all the way to the left and then all the way to the right. So that means it's all real numbers. So we can say all real numbers. Okay, -infinity to +infinity. You'll see this as an answer choice sometimes when it is, that's what the domain is, and you can choose that. In set notation, it looks a little different, okay? So we're gonna say that x, instead of writing like this, I think maybe MathSpace does do it like this with inequalities. So let's see, I'll give you that part as well. Let me rewrite it again. So basically you're saying that x is between -infinity to +infinity, okay? We can say that, or I've seen it written like this, where we say x is an element of all real numbers. This is a lot of symbols here to get used to it. You'll get used to it because you'll keep seeing these. But this means that x is an element of all real numbers. So these are the three different ways we say that the domain is going from -infinity to +infinity, okay? And then for interval notation, like this, we do have to use the infinity. So we're going to say it's going from negative infinity to positive infinity. And here I'm going to actually use an open bracket, parentheses, which we say open, because infinity is not closed. It keeps going. So we can't just say it stops at infinity, because infinity keeps going. So that's what we say, okay? By default, infinity is always open, okay? So that's that. All right, let's look at the range. So the range, it's going from bottom to top. So let me do this one for range. So range, it looks like it's starting at -3, and then it's going up, and it's going up to +1. That's the height, you can say, of the graph that we have here. So always for range, always start from bottom and then move up. So from negative infinity all the way up top. So in words, we say it's between, and always give the lower number first, -3 and 1. So in set notation, we're going to say y. We're going to use y because range is on the y-axis, the y values, right? Is between -3 and 1. And we're going to go ahead and close them because it's actually touching it at -3 and touching it at +1. Okay? And then if we're writing it in interval notation, we're going to give the two numbers from -3 to 1. And then we're going to go ahead and use a closed bracket because it actually includes it. Okay? All right, so let me go ahead and put the arrows for this graph here. When we're looking at the range, start from the bottom. There's nothing here, so it's not starting at negative infinity. It's starting actually at -1 here, and then it's going all the way to the top. It's going all the way to positive infinity. Okay, so it looks like it's going from -1 to positive infinity for the range. So we can say it's between -1 and positive infinity. So in set notation, we can do this. We can say x or y is between -1 and positive infinity. -1 is included because it's actually touching it at -1, and then infinity is by default always open. Okay, but we don't usually use this. I mean, I've seen this, but here's another way we can write this. We can say y is greater than or equal to -1. Y is greater than or equal to -1. So that's what's going to work. Interval notation, you just give the two numbers. So between -1 and positive infinity, -1 is included and infinity is always open. All right, so here is the next page. I'm gonna, just because the video is getting long, I'm gonna skip the top ones. I'm gonna go to the bottom ones here, number 4, 5, and 6. Actually, I'm just gonna do one. I'm gonna do number 6, and then we'll come back, and then I'll have you guys do the math space practice, and then go from there, okay? So for number 6, we have here, we're only looking at the domain. We're just practicing the domain. So remember, domain is going from left, from here. So that's at what, -2. And then it's going all the way here to 1, 2, 3, 4, 5. -2 to 5. So in set notation, we're going to say x is between -2 and 5. And then at -2, you notice it's a closed circle. So we're going to go ahead and put a line underneath to show that it's included in our domain. But at 5, there's an open circle, so it's not included. So I'll leave it open, meaning I don't put a line underneath, okay? And then in interval notation, we just give the two numbers. And then I'll go put a closed bracket for -2 because it's included. And then 5 is not included, so it's an open bracket. Okay, so that's that. And then let me go ahead and go to the next page. I'm sorry that I'm just not doing all of them, but we'll come back and revisit it. But I wanted to just give you an initial lesson here. When I'm looking at the range for number 13, I'll start from the bottom here. The lowest point right here is at -2, right? -2, all the way up to just right here. Not all the way, it just stops at +1. So it's going from, in set notation, we're going to say y is between -2 and +1. At -2, notice that there's an open circle, so I'll leave that open. And then at +1, there's a closed circle, so I'll leave that. I'll go ahead and close that one. Okay, so that's that. Interval notation, we just write the two numbers. And then at -2, it's open, and then at +1, it is closed. All right, I'm going to go ahead and stop the lesson here. This is just an intro. I'll make another video, probably a longer video with the rest of the examples. But yeah, that's domain and range. Thanks, guys.